Hello friends, welcome to the course Essentials of Data Science with R Software 1, in which we are trying to understand the basic concepts of probability theory and statistical inference. So, up to now we have understood that what are the good properties of an estimator, and once those properties are there, we can believe that this value is going to be a dependable and reliable value. So, now the question is how to get that value that you want to compute, or in very simple words, how to get an estimator of a parameter. So, now we are going to begin with this topic, that how are you going to estimate the parameters on the basis of a random sample. That means you have got the observation. Now, what you want to do? Do you want to take a sample mean, or you want to compute the median or mode, harmonic mean, geometric mean, etc. What, in case if you want to find out the central tendency of the population. So, now the estimate of the parameter depends on the population, and population is characterized by the probability density function. Now, we are going to talk about two methods in this course. One is method of movements and another is maximum likelihood estimation. I am not saying that these are the only two approaches to estimate the parameters. There are many approaches, but these two are the fundamental approaches and they give us a good value. And in the beginning of this course, when you are trying to create the foundations of this data sciences, then I think that these two are sufficient for you at the moment. But definitely I am not saying that they are the only one. You need to learn more, and now with the advent of the computer, more computational estimation techniques are there. So, let us try to begin this lecture and try to understand it. But before that, let me ask you a very simple question. Have you ever gone to a shop to buy some wheat or rice or some food grains? I am sure yes. Have you seen there is a big heap of the grains? There are 100 kg bags for the wheat, rice, etc. And you want to see what is there inside the bag, or what is the quality of the grain inside the bag. What do you really do? You simply try to take a small sample in your hand and then you try to see how is the quality. And if that small quantity of grain has got some holes, that means they have been infected by some insects, then you believe that okay, the grain inside the entire bag is also infected by the insects. And in case if you find that in that small sample, that is of say 100 grains, if there are an impurity, if suppose out of 100 grains there are 10 pieces of impurity, then possibly don't you think that you assume without thinking that okay, this bag is having almost 10% impurities. And on the other hand, if your all the grains are good, you assume that okay, the entire bag of the grain is good. Think about it, what are you trying to do? You are looking at the sample and then you are just magnifying it to the entire population, and whatever are the characteristics inside the sample, you are simply assuming that they are the same which are available in the population also. So, how this is happening? And that is the characteristic which I am going to use in the method of movements. Now, as soon as I say method of movements, I expect that you remember what we had learnt in the topic of movements. Means I had told you that okay, these are the things which are not going to be used as such, but they will help us a lot. So, now in case if you have not revised that part, I would request you that you first try to have a quick look on the movements, although I will give you here a brief information about those movements. I will try to repeat it, but surely if you understand it from your earlier lectures in detail, that will be helpful. So, let us begin with the method of movements. Okay. So, now as I said, we are going to talk about the method of movements and method of maximum likelihood. Method of movements we are going to talk in this lecture, and method of maximum likelihood in the next lecture. You can recall that we had considered the expected value of a function of random variable as expected value of x minus a raised to the power of a r, and this was called as the rth movement of x about the point A, and it is defined in the population. This is what you have to keep in mind. You can see here, this is the expected value. And in case if you try to take this capital A point to be 0, then we say that the rth movement around the origin A equal to 0 is called as raw movement. And in case if you try to compute this population value on the basis of the given sample of data, say x1, x2, xn, then we try to define the rth raw sample movement as, say here, mr prime, which is equal to 1 upon n summation I goes from 1 to n xi raised to the power of r. Right. So, this is your here rth sample based raw movement of x about origin. And in case if you try to take here a is equal to expected value of x, that is the mean, then expected value of x minus a raised to the power of r, this becomes here expected value of x minus expected value of x raised to the power of r, which is equal to here mu r, and mu r is called as the rth central movement of x, and this is again defined for the entire population that you can see here, right. Mu is the mean for the entire population, for example, and similarly the mu r is the means rth central movement for the entire population. Now, in case if you want to compute it on the basis of given sample of data, then the rth movement of a variable x about mean based on the observation x1, x2, xn is defined as, say, mr, which is simply 1 upon n summation I goes from 1 to n xi minus x bar raised to the power r. So, this is only the arithmetic mean of the deviations xi minus x bar with our r, and this mr is called as the rth sample based central movement of x. Right. Now, I try to give you here one property which I am not going to prove, but I am just stating it. Do you remember the definition of the convergence in probability that we had used earlier also in the case of consistency of the estimator? So, we try to say that xn converges in probability to x, that is xn is going to x in probability as n goes to infinity if probability that absolute value of xn minus x is greater than epsilon is going to 0 as n goes to infinity for all epsilon greater than 0, or the absolute value of the deviation of xn and x, the probability of this event is smaller than epsilon is going to 1 as n goes to infinity, right. So, now based on that I can inform you that using the weak law of large number we can show that mr transpose converges to mu r transpose in probability. That means the rth sample based raw movement tends to the rth population based rth movement, rth raw movement, and this convergence happens following the rules of convergence in probability. That means probability that absolute deviations of mr prime and mu r prime is greater than epsilon is tending to 0 as n goes to infinity for all epsilon greater than 0, and the probability that the absolute deviation between mr prime and mu r prime are smaller than epsilon is going to 1 as n goes to infinity for all epsilon greater than 0, right. So, this means if you try to increase the sample size, your rth sample based raw movement will converge to the rth population based raw movement. Now, you have seen this type of picture. Well, these are the places where people try to store the grains, and there are so many bags of, and possibly every bag has a weight of 100 kg, but whenever we want to buy the wheat, we will simply take out one bag and we try to look into the quality of the wheat by drawing a sample like with this type of instrument, or we try to simply use our hand and we try to look into the quality of the wheat. Okay. Now, and then what we try to do, whatever is the quality that you are trying to estimate here, you try to equate this quality that you have obtained on the basis of a sample to the entire population. So, whatever is the quality in this amount of wheat, that you try to translate it to this entire bags. And similarly, if you whatever is the quality that you are obtaining through this small instrument, that you try to translate it to this entire population of the bags, right. So, that is the concept here. You are trying to assume that whatever are the characteristics, whatever are the properties which are contained in the population, they are also in the sample, and whatever are the properties that we have learned, they can be prescribed through the movements. So, what we try to do here, that we try to equate the population movements, right, to the corresponding sample movement, that is all. The population movements, they are defined in terms of expected value, and they are going to be function of some unknown parameters. And then we are going to have such equation, we try to solve those equations, and they will try to yield the estimators of those unknown parameters, and they are called as method of movements estimator. So, formally I can say that let x1, x2, xn be a random sample from a probability density function or from a probability mass function, whatever it is, and suppose there are p unknown parameters theta 1, theta 2, theta p. So, in order to find out the method of movements estimators, what we try to do, we equate the first p population movement to the first p sample movements, and then we try to solve those equations, and the solving of those equations results into the value of those parameters which are the estimators, and those estimators are called as method of movements estimator, or say MOM, method of movements estimators, right. So, let me try to take here some example to show you that how the things work. So, let x1, x2, xn be a random sample from an exponential distribution with parameter lambda, and whose PDF is given by this fx is equal to lambda exponential of minus lambda x, where x lies between 0 and infinity. Now, you can see here there is only one parameter here. What is that? Lambda. So, what you try to do? Now, if you try to look into this definition theta 1, theta 2, theta p, now here in this case p equal to here 1, that means there is only one parameter, theta 1 is equal to lambda. So, this means we simply have to compute the first raw movement based on sample and population. So, the first raw movement based on sample is indicated by m1 prime, and this is equal to here capital X bar, and the first raw movement based on the population is here mu 1 prime, which is actually here expected value of x. So, now I simply have to substitute mu 1 prime is equal to m1 prime like this, and once you try to do it here, you can see here that sample mean capital X bar becomes equal to, see here, 1 upon lambda, because we know that in the case of exponential distribution, the expected value of x is given by 1 upon lambda. So, now you can see here, this is what I have written here. Now, once you try to solve it here, this will give here say lambda is equal to 1 upon x bar, and hence lambda hat becomes equal to 1 upon x bar, and this is here the method of movements estimator of lambda, right. Now, in case if I ask you that can you really find it on the basis of r, do you think that finding out the value of 1 upon x bar is difficult? Right. So, now let us try to take an example and try to show you that what do we really mean by this estimator, and how do we interpret it, how do we calculate it on the basis of R software. So, now we have understood that in this case lambda hat is equal to 1 upon x bar is the method of movements estimator for lambda, right. So, now suppose we have some data set on the time to failure of our TV set, right. So, certain number of TV sets are tested, and it has been recorded that after what time they are going to be failed, and the time to failure is exponentially distributed, because this is a lifetime. Now, you see, in reality, if you are trying to deal with such situation, now you know the basic background that if you are getting a data on the lifetime of a product, then possibly exponential distribution can be used here. So, this test is conducted on 10 units which are randomly selected and tested, and this following values are obtained on the number of playing hours. So, the first TV set went for 100 hours, second TV set went for 105 hours and so on, and the 10th TV set lasted for 109 hours. Now, you want to know what is the average life after which the TV set may fail to work. So, that means now you have to take a call what you really want to know, mean or variance or skewness or kurtosis. This question can be answered by considering the mean of the population, and now you are trying to employ the method of movements to find out the mean of the population, and you have obtained that the method of movements estimate is 1 upon x bar. So, now you simply have to compute the value of 1 upon x bar on the basis of this given set of data. So, now if you ask me that how to compute this value in the R software or any software, I will say simply try to enter the data like here this, and simply try to use the command 1 upon mean of x, where x is the data vector containing all such observations, and you can see here this will come out to be here like this, right. So, you can see here now estimating the parameter is not difficult at all, and once you have obtained the value of the lambda, you can compute different types of probabilities. Now, the complete distribution here is known to you. If you try to see here, now this entire PDF is known to you, because lambda is known to you, and that is why lambda was called as a parameter. Once you know the probability density function, you can draw any type of information what you want, right. So, that was the advantage. Now, let me try to take one more example, very simple example. Suppose let x1, x2, xn is a random sample from a Bernoulli distribution with parameter p, whose probability mass function is given here like this, right, that we know, and in this case also there is only one parameter p that we want to estimate. So, once again I have to do the same thing. The sample based first raw movement is here m1 prime, which is equal to here x bar, and the mu1 prime, which is the first raw population movement, this is expected value of here x. Now, expected value of x that we already have found, this is equal to p. So, you try to equate both here, say m1 prime is equal to mu1 prime, and we get here x bar equal to here p. This is what I have done here, and now once you are getting this thing, then I can write down here that p hat is equal to x bar. That means, the method of movements estimated for the population proportion in the case of Bernoulli distribution can be estimated by the sample mean, and this is the method of movements estimated of p. So, now if you ask me how to compute the mean, do you think that should I inform you? Yes, I should, because one can calculate the method of movements estimated in R as the command mean, that is all. So, you can see here that life is now become so simple, so easy once you know all these things, right. Now, I try to give you one more example. Suppose x1, x2, xn, they are a random sample from a uniform distribution, uniform 1 theta, where this fx is 1 upon theta if x is lying between 0 and theta and 0 otherwise. So, in this case we have to do the same thing. The first raw movement m1 prime is obtained here as a x bar. The first raw population based movement, that is given by expected value of here x, right. So, and then I have to simply equate it. So, and in this case, if you try to find out the value of expected value of x, this is going to be simply 0 to theta x 1 upon theta into dx, and if you simply try to obtain it, this will come out to be theta by 2, right. So, that is what I try to equate here, that m1 prime is equal to mu1 prime, and then this will become here x bar is equal to theta upon 2, which I have written here. And now, once you do this thing, This will imply that theta hat is equal to twice of x bar, and so this theta hat is the method of moments estimator which is equal to twice of x bar for the parameter theta. So, now if you want to compute this estimator, you have to simply write down here 2 star mean in the R software, right. This is pretty simple. Now, similarly, if I try to take here the last example, that x1, x2, xn, they are coming from a normal distribution with parameter mu n sigma square, and their PDF is given here like this. Now, in this case you can see there are 2 parameters, one is here is mean and another here is variance. So, what we have to do here, we have to find out the first 2 sample based raw movements and first 2 population based raw movements. So, we need to find out here m1 prime and m2 prime, and then we need to find out here mu1 prime and mu2 prime, and then we have to equate them. Now, here we have here 2 equations and 2 unknowns, and we simply solve them and get the value of mu and sigma square. So, that is what I am going to do here, that m1 prime is equal to expected value of x, that is equal to mu, and m2 prime is expected value of x square, that you can obtain very easily, that variance of x is equal to expected value of x square minus expected value of x whole square. So, variance here is sigma square and expected value of x square minus mu square. So, you can very easily compute that expected value of x square is equal to mu square plus sigma square. So, we try to equate mu square plus sigma square to summation I goes from 1 to n xi square divided by n, right. So, we try to now equate here x bar equal to mu, and mu square plus sigma square is equal to 1 upon n summation I goes from 1 to n xi square. So, now if you try to solve this thing, this is giving you directly here that mu hat is equal to x bar, and if you try to substitute these values over here, you can obtain the estimate of sigma square as here like this, right. So, here the method of moments estimator for mu is this sample mean, and now for the method of moments estimator for the variance, you can write down here the same thing, 1 upon n summation I goes from 1 to n xi square minus, say instead of here mu, you try to replace mu by mu hat. So, this will become here minus n mu hat square. So, this becomes here n times x bar square, and if you try to solve this quantity, this is simply here 1 upon n summation I goes from 1 to n xi minus x bar whole square. So, now you can see here, now you have got here a population normal mu sigma square, you do not know the value of mu, you do not know the value of sigma square. I am simply now giving you this very simple solution, just use the method of movements, and that is trying to indicate you, or that is trying to inform you that the value of mu can be obtained just by finding out the arithmetic mean of the sample observation, and the value of sigma square can be obtained by the sample based variance, which is given here like this. So, this mu hat and sigma square hat, they are the method of moments estimator for mu and sigma square respectively, right. And one thing I can just show you, and you can verify it here, that this x bar is an unbiased estimator of mu, whereas this sigma square hat, which is obtained here as the method of moments estimate, this is a biased estimator of sigma square. In fact, if you try to make a small modification, then this sigma square hat can be converted into an unbiased estimator. What is that modification? Just try to take in the denominator n minus 1. So, if you try to take another estimator of sigma square as sigma square hat, which is 1 upon n minus 1 summation I goes from 1 to n xi minus x bar whole square, then this will become an unbiased estimator of sigma square. Well, this is not a method of moments estimator, but still I thought I should inform you, because many times we have used these 2 forms, and always I was telling you that these 2 estimators will have different properties. So, you can see here that in these 2 forms, with the divisor 1 upon n and then with the divisor 1 upon n minus 1, the estimator with the divisor n minus 1, that is going to be an unbiased estimator, whereas the estimator with the divisor n, this is a biased estimator. And now you understand what is the meaning of biased and unbiased estimator. Also, in case if you try to think about the variability, here the quantity in the numerator, this is the same, summation I goes from 1 to n xi minus x bar whole square in both the estimator. The difference is coming only in the denominator, that in the method of moments estimator this is divided by n, and in the case of sigma square hat this is divided by n minus 1. So, obviously, this estimator will have a smaller variance than this. Why? In case if you try to take some quantity here a square and try to divide it by here 9 or say a square divided by 10, what do you think which is a smaller quantity, right? That is a very simple thing to understand. Okay, so now we come to an end to this lecture, and now you can see here possibly this was one of the most interesting lecture of the entire course. Now, here you are able to implement all the things what you have learned, but my first question to you all is that I am sure that up to now you must all be getting extremely bored, because I was trying to initiate different types of concept. Sometimes there is some probability, sometimes there is probability function, sometimes there is a continuous random variable, sometimes it is a discrete random variable, etc., etc. But now you can see after this lecture I am asking you a question and I will leave the answer up to you. If you had not understood those basic fundamentals, can you really understand anything in this lecture? This is the lecture which you wanted right from the beginning, that how are you going to estimate the unknown parameters. Now, in case if I tell you, okay, you have got an exponential population, you try to estimate the parameter lambda by 1 upon mean, and if you have a normal population, try to estimate the population mean by simply by sample mean. How do you know which one is correct? And I would like that you take this call, not me. But if you do not know these fundamentals, how will you know that whether the mean has to be estimated by x bar or 1 upon x bar? So, that is precisely what I told you in the beginning of the lecture when I posed the question before you, what you really want to be, a compounder or a doctor. I am sure that now you are going to becoming the doctor very soon. So, you try to have a look into the books, try to take some examples, try to practice it, and I will see you in the next lecture with method of maximum likelihood. Till then, goodbye.